Uh, we seems like we're good to go.
All right.
I'm just gonna do hi guys, so welcome to our AMA. My name is Jason, and I would like to welcome Gayle McDowell. So Gayle McDowell was a founder, software engineering author. Her latest venture career, her latest venture. Sorry,
All right.
what? I'm just gonna do hi guys, so welcome to our AMA. My name is Jason, and I would like to welcome Gayle McDowell. Did you hear that?
Yeah, we heard that.
Yeah. Okay. My bad. Yeah. So, she's known for antifreeze, and most notably, you're known for the author of the CTCI book, right?
Mm-hmm.
So, I myself am a big fan. I have not, however, bought your book yet, but it's in my shopping cart. So, without further ado, Gail, you can start your keynote.
Okay, thank you guys so much, and thank you everybody for joining us. So I'm going to switch over to my slides shortly, but so I'm going to talk about a kind of 30-minute-ish talk about coding interviews and kind of what they're all about and how to do well in them. So let me see if I can successfully switch over.
Awesome.
And can you guys all see my screen?
I see clearly.
You see the slides?
Yep, I see.
All right, awesome. Okay, so yeah, so my background is I come from a computer science background, did bachelor's and master's at Penn, and did an MBA, but we don't like to talk about that much. But most of my time was spent as an engineer. So I was at Google for a while, as well as Microsoft and Apple. Was a software engineer there, but at Google and Microsoft and Apple, and did a lot of work on Google. Got brought into Google's hiring committee. Did a lot of work with doing interviews, and after Google broke off on my own and founded Career Cup, which is sort of a company that does various things around interviews. So that means that I do, I have my books, Cracking the Coding Interview, Cracking the PM Interview, Cracking the Tech Career, as well as a fourth one, hopefully coming out in January, called Cracking the PM Career, which is sort of supposed to be a job guide for product managers. And some of the other things I do is I work with companies I work with startups going through the acquisition process. So when startups get acquired, they often get interviewed essentially for their own jobs. And so I work with startups going through the acquisition process to prepare them for the interviews. And so that's allowed me to do is interview the same person repeatedly and see what helps them do better, and what kind of things are they messing up on, what's going on when you see somebody who is seemingly doing a really good job at work, but at the same time isn't doing so well in these interviews, and figuring out how to help them really do their best. And then I also help companies on the other side, I've helped a number of the bigger tech companies with building out their hiring process, running interviewer trainings. And so I can also talk a lot about the other side of that. So the slides are going to run about 30 minutes. They are online. You can either go to this link at the top, or if you shoot me an email with the email prep@gayle.com, it'll just give you an auto response. Subject doesn't matter. I'll just get auto archived anyway. It'll give you an auto response with a link to the slides and a few other materials that I'll talk about, that I'll reference later on. And of course, you feel free to take screenshots if there's anything you want to particularly record, but the slides are also online. Okay, so first of all, what the interview is all about. These interviews are about problem solving, and this is something that I think has gotten lost in the way that a lot of people do interview prep. They focus so much on, I learned, I'll see these people who post like, I did 500 interview questions. I'm like, well, great, but if you did 500, did you really do them, or did you read the solutions to 500? Because those are very different things. These interviews are about the actual process of solving problems, not seeing if you know the solution to a problem. So it's a verb, not a noun. It's problem solving. So you are not expected to know the answers to the problems. In fact, when I ask a candidate a question, I really don't want them to know the answer. Because I want to see if they can figure out how to derive the answer. And if they already know the problem, that doesn't make them smart. It means that they just know the solution. They've memorized something. That's great, but I can't evaluate what I'm trying to evaluate, because I'm trying to see how effective of a problem solver they are. I also don't really expect a candidate to be so incredibly brilliant that they, as soon as they hear a problem they've never heard before, they just whiz through it and solve the problem immediately. Like I have seen candidates who can do that, and that's fantastic and that's amazing, but that's not a realistic expectation. That's so rare. The vast majority of candidates who get hired are not that strong. They are very bright and they work hard and they can solve a hard problem, but they aren't just whizzing through it knowing the answers. Likewise, I also don't expect that you are a perfect coder. Almost every time, even the successful candidates have some bugs, some problems with their code. So certainly, to be clear, more perfect, better solutions, faster solutions is better than less, but I'm not expecting that because it's just so rare. What I really want to see, though, is the thought process. A really simplistic way of thinking about these interviews, and this is something companies don't like to say because it can kind of upset people, is these are effectively intelligence tests. They are a particular type of intelligence. It's not a perfect measure, blah, 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 but they're effectively intelligence tests. And that's going to be a very simplistic but useful way of thinking about them. So what I want to see is your thought process. And that doesn't mean that I'm looking at it as like, how long did it take you to get to the optimal answer? In fact, I can have one candidate who takes 20 minutes to solve a problem do much worse than another candidate who got to the same solution after 30 minutes. Because when somebody is struggling, I give them more help. When somebody isn't struggling, I give them less help. So people can take the same amount of time to reach the same answer, but one person do much better than another because one person got a lot more help than the other. So it's very much about the thought process. And that's why it's really, really important that you explain your thought process to your interviewer, that you talk out loud. I also really want to see real code in the interviews, and not meaning I don't want you to write pseudocode. And the reason for this is that what I found is that when I allow people to write pseudocode, when I say, okay, fine, pseudocode is okay, is that it becomes like you're playing a game, but nobody knows what the rules are. So one person's version of pseudocode is like something that looks like pretty much very close to Python. Looks like code with bad syntax. Another person's looks like what you'd find in the big like CLRS algorithms textbook. And another person's is like, well, step 1, walk through array. Step 2, do this. And it's very difficult to really compare them. The other thing is that it creates this, it allows people to be sort of hand wavy. So someone will say, sure, someone will say, oh, I'm going to put these items into a list, and they won't ever stop to think about what type of list it is. And it matters often what type of list it is. It matters whether you're using a linked list or an array or whatever. So it's much easier for interviewers and much fairer for everybody if the interviewer says, you know what, write real code. Yes, write every semicolon or whatever. That said, on the interviewer side, I don't necessarily expect syntactically perfect code. If you make mistakes, I'll adjust, and it's not like you have to write flawless code. That's, again, as I said, that's rare. So the way I think about code, and in fact the interview as a whole, is that it's about signal, not perfection. So if you look at these two pieces of code, both of these are Java code, and both of these pieces of code are actually wrong. Compiling is more or less a binary thing, and in this case, neither of them compile. But the first one, it absolutely flat out would not compile because it should be list.add, and I wrote list.insert. If a candidate does that in an interview, I'm not going to look at that and say like, oh, well, they're not a good coder because they wrote list.insert instead of list.add. I would look at that and be like, okay, so what? Sure, it doesn't compile, but so what? That doesn't signal you're a bad coder. The second piece of code, if somebody writes at an interview, and it's, maybe it's different if someone's just learned to code, but in that case, they're probably not going to get hired right now anyway. But the second piece of code also is compile problem, but it screams a much, much bigger issue. And now that's assuming that this was an actual confusion. If you had a typo in your code and it doesn't compile, and then you're like, oh, duh, double equals, no worries. But so my point is that the way the interviewer looks at your code and even the problem solving process and even the behavioral questions is not about, did you do it right? It's about, okay, look at what you did. What does that tell me about you? Code can be wrong and broken, and I can see, well, you're a great coder actually. And code can be, code can even be right and still think you're a bad coder because it's sloppy. So, and of course, code can be bad and you're a bad coder, right? So everything is about what is the signal I'm learning from this, not this binary metric of is it right or is it not. Okay, so I hope that kind of that general context makes sense to people. There is going to be some Q&A after this, so if you have more questions, feel free to ask about this. For anyone joining later who didn't catch it, the slides are online. I have a link. I'll show it again at the end. But you can also just shoot me an email at prep@gayle.com, and that'll give you an auto response with the slides and some other materials. So let me talk to you now about what to expect in the interview. So it does depend on the company. And you can, if the company didn't, I really encourage any company I work with to be really explicit about this and say, like, here's exactly what your interview will entail. But if the company doesn't tell you, feel free to ask. Most companies will tell you if you ask. But what you'll typically see in the coding interview is a few minutes at the beginning about behavioral questions. And this can be often something like walk me through your resume or tell me about this project. And then a few minutes at the end where you get a chance to ask the interviewer questions about the company. But the bulk of the time is spent on coding questions. Usually you'll see one or two questions, sometimes more. Whether you see more or less has a lot more to do with, like, whether you see two questions or one question is not really about your performance as much as how the interviewer handles interviews. In my interviews, I rarely ask more than one question because I prefer to ask a pretty challenging question and help somebody as needed than ask two easier questions. But other interviewers take a different approach. But it's usually one or two questions. The way that the questions are handled, or at least should be handled. Now, one thing I want to be clear here is that, I've done interview training for many of the companies. I've not trained every single interviewer at every single company. And even if I had, it doesn't mean that I could make them all do the right thing. So what I'm talking about here is a little bit like, this is best practice. This is what interviewers should be doing. Most kind of are doing this. Some don't do a good job of this. But sort of the way that the typical process coding question happens isn't like I ask you a question and then you do what you want for 30 minutes and we come back and see how you're doing. Rather, it's more like I ask you a question, how would you design the algorithm to do such and such? You maybe rephrase a problem, ask some clarifying questions. You do what you need to make sure you really understand the problem. Usually that's actually a very quick process. It's not 5 or 10 minutes even of questions. It's usually, I try to ask my questions so that they're pretty clear and you don't have a whole lot of follow-up questions to ask. But certainly it's common to have some follow-up questions. So you clarify your understanding of the problem. And then usually you go up to the whiteboard, you draw an example of the input and output, and you try to come up with a brute force algorithm. Maybe the brute force algorithm is even obvious at the very beginning. But you come up with a brute force algorithm, you draw an example, and you don't go and code yet. You go and generally, and I'm going to talk about this later on, but you go and you optimize, and eventually you code. Maybe after you code, you go and test it. Usually, maybe after that, you have more time, you continue to optimize or something like that. During this whole process, it should be a collaboration. Obviously, as an interviewer, I know the answer. I should know the answer anyway. But it is a collaborative process. So during this process, I'm making suggestions, clarifying things, guiding you away from things like that. But it should be a collaboration. Now, how much I collaborate with you depends on a lot of things. It can depend on my personality, for one, but it can depend often on how you're doing, how much help I think you need, how hard the problem is. It can also depend on my sort of feeling for how you're reacting to help. So every once in a while, I see candidates who I get this sense that every time I make a suggestion, they're interpreting this as like they messed up. And at that point, I might pull back and give them less help, which doesn't necessarily hurt them because I'm going to adjust my expectations for them, taking into account that they got less help. But this whole process is a collaboration. It's not I sit silently while you solve the problem. So let me talk to you about how to actually go through and solve problems. There is a process that works pretty well, and I really, really encourage you to stick to this. So I have a worksheet or a handout online at crackingthecodinginterview.com. If you click on resources, or that auto response will give you a link to it. And it gives you basically a flow chart for how to work through problems. I really, really encourage you to follow this process. It has helped so many candidates, and that really means follow it step by step. So as you're preparing, have this out, and you can even make a little checklist of like, okay, did I listen or read the problem carefully? Did I do the example piece? And there's kind of sub steps under each of these that you really, really want to pay attention to. The vast majority of times in interviews, when candidates are struggling, they would do better had they followed this process. So first step is listen to the problem. Seems obvious, right? You, of course, have to make sure you understand the problem, but I'm saying a step deeper than that. I'm saying listen to the clues in the problem. So let me give you an example. Given two arrays that are sorted and distinct, find the number of elements in common. Now, here's something you want to understand about interviews. Generally speaking, interviewers don't give you unnecessary details in problems. So think about that. Interviewers do not give you unnecessary details. That means that if a detail, a fact, whatever is in the problem, the optimal answer depends on that detail, which means, one, if you forget that detail, you're probably out of luck for solving the problem optimally. It means that if you have a solution and it doesn't use some fact of the problem, if the solution would work just as well if that fact weren't true, it's probably a sign that your solution isn't optimal. And it also means that if you dissect the problem, you can often find clues of how to solve the problem by listening and thinking about what does that fact tell you. So let's go back to this problem. Given two arrays that are sorted distinct, find the number of elements in common. So there's a detail here that's really important, which is these arrays are sorted. So you should really pay attention to that. Why does it matter that the arrays are sorted? And so you want to think about what does that do? What does sorting the problem do? What does having these arrays sorted do? Well, it allows you to, in this case, you work through it and it allows you to do something with finding using the kind of a binary search like algorithm or a kind of a sorted merge problem, the approach to do this. And if you forgot the detail, forgot that the arrays were sorted, you'd be basically out of luck. So it's super, super important that you pay attention to those details, remember that sorted, or you just won't be able to solve the problem at all. Second step is to draw an example. This is extremely important, and so many candidates don't do this or don't do a good job of it. And interestingly, it seems to be particularly common for the people who are really strong problem solvers to not do this. And I think it has to do with that people who are very strong with these kind of problems are used to being able to do so much in their head. And the problem is that's okay with an easy problem, but as soon as the problems get hard, that becomes much harder to do. And they end up struggling more than they should because they don't draw an example. So it's really, really important that you draw an example of what the input and output would be. Let me show an example of this. Let's go back to this problem. Given two arrays that are sorted distinct, find the number of elements in common. So think for a moment in your head about if you got this problem in an interview, what kind of example input would you provide? Or would you put up on the whiteboard or the screen or the text editor or whatever? Most people, again, think for a moment in your head, picture what your example would be. Two arrays sorted distinct, find the number of elements in common. Most people's example looks something like this. Two arrays, often 4 elements both. And the problem with this is if you look at this example, and remember the output is how many elements are in common, you look at this and like almost at the first glance, you know that the output is 1. You see that there's only 12 in common. This is really small and kind of a special case because there's only 1 element in common and the arrays are the same length and the element in common is actually at the same index. That's not going to be very useful. This is a more useful example. Look at this one and find the output. It's not going to be extremely hard to solve the output, but to find the output, but you're going to be seeing your eyes kind of darting around, trying to match up elements and figure out what elements are in common. That is the start of an algorithm. So you want an example input and output that makes you work for the output. You want something that makes you do work. That's not just like you glance at it and you know what what the output is. So that means that your examples should be large, a little bit larger than is super comfortable, and generic. So really try to avoid those special cases. If you can glance at your input and know the output, you probably did something wrong. You probably want a more complex input. Again, you want yourself to have to do work, because that work is probably the start of an algorithm. So really, really important and so easy to do. It's so easy just to say when you're in the interview, I'm going to make sure my examples are big and I'm going to try to avoid any special cases. Such an easy thing to do that helps you do so much better in interviews. Third step is just come up with brute force. Anything is fine. It's so much better to have something than to have nothing. So years ago, when I was in a interview, I think it was with Amazon, I was asked an interview question, and I spent 10, 15 minutes trying to come up with an answer. And about 10 minutes in, the interviewer was like, well, you can do it this way. And of course I did. That algorithm was obvious. So it was so obvious that I didn't tell the interviewer that I had that solution, because I kind of thought, well, everybody knows it's not even useful to say. Now, looking back on this, having been an interviewer, I know that actually not everybody does know that that's a way of doing it. And so to that interviewer, I looked like to be blunt, I looked like the idiot who couldn't even come up with the obvious answer, which is not a good place to be in. So you don't want to be that. You want to be stating the brute force in the very beginning. If the brute force is obvious, just state it. Now, to be very, very clear here, I'm saying you state the brute force, you state the runtime, and then you go and optimize it. Do not code yet. It is so much better that you have some algorithm that is slow and terrible than to have nothing at all. And I'd even say, if you're in the interview and you're thinking, I don't have anything, stop and take a step back and say, is there a really stupid way of doing it? If you're supposed to find the smallest subarray that has some property, well, what's a really stupid way of doing it? I don't know, come up with all possible subarrays, see how many, and then pick the smallest one of those that has some property. All right, think about the stupid and slow, obvious way. The other reason why it's really important to do that is that very often you can start with the brute force and optimize from there. So remember to get a brute force out the door, state the runtime, and just state the algorithm, state the runtime, and optimize. Do not code, because your interviewer may not want to see that piece of code. And if you go and code something they don't want to see, very often the interviewer will kind of not give you credit for that code. So you will basically eaten up 15 minutes of time coding something the interviewer never wanted to see. Now, I want to be clear that that is really unfair. That's a bad interviewer. They should have, if they didn't want to see you code that thing, they should have stopped you. And frankly, as an interviewer, I'm actually totally fine with someone coding the brute force, because I can evaluate their code just as well from the brute force as from an optimal algorithm. But not all interviewers are me. So state the runtime, state the brute force, state the runtime, and you can ask them if you want them to code, but do not just dive into coding unless they tell you to do so. So next step is to optimize. And this is where you're going to spend usually the bulk of time in an interview. So there's a couple techniques for optimizing that I'm not going to talk about too much here because we don't really have time, but you'll find this in Cracking the Coding interview. If you go to these slides online, I have, if you look at it not on projector view or whatever, but you look at it just the editing view, you'll be able to see slides that actually show these. I just have them hidden for the sake of time in this interview. But one of the things I want to mention here is the do-it-yourself approach. And what that means is basically forget about computers and algorithms and all this stuff. Take your brute force out, or take your example input and just try to solve it just for that one thing, not with an algorithm. Just figure out what the output is, which you may have actually already done in step 2. and think about what is it that approach, how is it that you solve the output manually? And that will often be an algorithm. But I go into a lot more of these details on the, in my book and also in the slides. But one other thing I want to mention here is keep working at it. Problems are supposed to be hard. They're supposed to take some time to optimize. That is totally normal. Keep working at it. One of the biggest red flags is when candidates give up in problems. So just keep working at it, keep trying to optimize. Next step. Once you have your algorithm, it's optimal. Your interviewer said, go ahead and code. Don't code yet. Again, quick, easy way to do better in interviews. Don't code yet. Take a moment, walk through your algorithm again, make sure you know exactly what you're doing. Walk through it and think about, you should, in an interview, code is only like 10, 20 lines. Usually it's not all that much. You should be able to basically picture your code before you start writing. And you should certainly know what your variables are, what the data structures are, how do they change, how your code is structured, are you using any subroutines? You should have a pretty good mental model of what your code looks like before you actually start writing it. And certainly, if you have any little math, any like annoying little ways that the indices are manipulated or whatever it is, you really want to make sure you get those down before you start coding. And if you're ever in the middle of coding and you get kind of confused, don't try to plow through. Take a step back, walk through it again, just on an example, understand your thought process, and then go back to it. When you plow through your code, it's kind of like if you are driving somewhere and you, rather than, and imagine you don't have, Google Maps there or something like that, and you just leave your house taking off for this destination, and you kind of sort of know what you're doing, but you don't know exactly where you're going. That's not going to be a very efficient way to get there. It's much more efficient to know where you're going in advance. Stumbling around, hoping you get to the right destination tends not to work very well, particularly with code. So before you start coding, walk through, understand exactly how you're approaching it. And once you really, really know what you're doing, then you can go ahead and code. And one of the problems that happens here is people are so used to coding on a computer and so used to coding privately, where you can rush in a little bit easier and it's not a big problem. But when you're in an interview, you're in a time constraint, somebody's observing you, and the problems are usually disproportionately hard for only being 10 lines or so, you really want to make sure you know exactly what you're doing before you start coding. When you start coding, remember that your goal is to show me signal that you are a great coder. So yes, that's about correctness. Yes, it's about performance. But it's also about readability and maintainability. So write beautiful code, not just correct code. So good variable names, things like that. Error towards more modularization, things like that. Show me that you are a great coder. And then lastly, test. It's really, really, really important to interviewers that you test your code. One thing to note here is that a lot of times people will take the example that's often still up on the whiteboard or the virtual whiteboards of the text editor, and they'll just throw that into the test case. That can be okay if you're running an automated test, but if you're testing by hand, it's way too time consuming to use a giant example to test your problem, to test your code. What's a better approach to doing it is actually to first do conceptual testing. So that means not with a specific test case, just do a conceptual test, which means walk through your code line by line, like a really detailed code review, and really think, what is it doing? What are the potential problems here? And just conceptually think it through. Then double check any high risk lines of code. So any little array manipulations, indice manipulations, math, things like that. Double check the high risk lines of code. Then go to test cases. With test cases, start with a small test case first. The bugs, generally speaking, the bugs that happen when you throw in 10 element arrays tend to actually happen with 2 element arrays too. Except the 2 element arrays find that bug way faster. So start with small test cases first, then some of the edge cases, and then maybe if you have time, big test cases. But make sure you actually test your code. And the other thing I want to throw out here is make sure that you're testing your code and not your algorithm. It's amazing how often I'll see people, and they probably believe that they're testing their code, yet they're not actually looking at their code when they're doing it. They're not actually thinking about the variable represents this or whatever it is. They're kind of running through their example, not looking at their code at all, which means that they're not testing their code, they're validating their algorithm. This is the time to be validating that your code is doing the right thing. So actually walk through it line by line, plugging in every value for the variables, things like that. Okay, again, this is kind of the thought process. I really, really encourage you to follow this process. So let me wrap up with a couple of things that are common mistakes I see. First thing, and this is somewhat repeating some of the stuff I mentioned earlier, but I really want to re-emphasize that. First big mistake is people who don't have examples up on the whiteboard. As I said, you want an example that is big and generic. Second thing is people who code prematurely. That happens in one of two cases. Either they are coding when they don't understand exactly what they're doing, or the other piece of code that the other time when it's premature is when the interviewer hasn't actually signed off on coding. So you start coding, you write your algorithm, or you come up with your algorithm, you start writing your code, and your interviewer doesn't actually want you to write that piece of code yet. So simple thing, make sure that your interviewer has explicitly told you to code. You can ask them explicitly, hey, do you want me to code? And then they hopefully say yes. Or you can, sometimes they tell you to code even when you hadn't asked them yet. Either way is fine, but you want to make sure you have an explicit verbal sign off to code. Third thing is coding that's sloppy. One of the ways that happens is when people have done a lot of competitive coding or automated kind of interview prep sort of things, and one of the problems is that those environments don't usually check the quality of your code. They just and they end up encouraging sort of sloppy coding. So make sure you write good code, readable, efficient, maintainable. More specifically, that means modularization, good variable names, and optimized code. Fourth mistake is people who ignore me. So what I mean by that is, as the interviewer, I'm here to help you. So I might give you hints, and I usually won't say, here's a hint, do this. Often I'll do it in questions that are like, what if you thought about the array as a list of menu items? What would happen if you had a single element array? Now, what about a 2-element array? Now, what about a 3-element array? And when I stop asking that question, I ask about 1, 2, and 3, maybe go to 4. I remind you, hey, don't forget that the data is sorted. Assume that if I'm speaking up, I'm doing it because I want to make a suggestion. I want you to change something you're doing. I want to tell you something. So pay attention to that kind of help I give you. And certainly anytime, if you ever hear me say more than once something like, I told you, hey, don't forget that the array is sorted, and then 5 minutes later, I tell you again, remember that the data is sorted. That's a really big red flag. That's like a screaming red burning flag that you need to pay attention to the fact that the data is sorted. And I really want you to do that right now. So pay attention to your interviewer, pay attention to things that they say. The last mistake I see a lot is people who just try to memorize too much. There's been this, in the last few years especially, there's been this explosion of interview prep. And this idea that people have that they need to spend 6 months preparing for interviews. And it's just like, whoa, relax. You're supposed to be solving problems from scratch. You're not expected to know the answers to these problems in advance. If you don't know how to solve the problem that you get, great. That's what I expect. That's what I assume. That's what I want to be the case. Because I want to know, what do you do when you don't know how to solve the problem? You do want to practice interviewing somewhat. You want to practice different ways of solving problems, not as much in terms of very specific algorithms to solve problems, but more in terms of practice, using larger examples and practice talking out loud. Yes, to do some interview prep, you don't need to do 6 months of interview prep. And when you do that, it often backfires because you've memorized so many solutions at this point in time. Your interviewer may actually have trouble evaluating you. You may be tempted to pretend like if you already know the answer, pretend like you don't know the answer, which is an automatic rejection for many interviewers. And if you don't understand that, feel free to ask about that in the Q&A after this. Or you just get in this mindset of like, when you don't know, when you got a problem you haven't seen before, that's like, oh no, I'm not prepared for this problem. Whereas you should really be like, great, that's what's to be expected. So yes, to interview prep, you don't need to practice hundreds of problems and spend 6 months preparing for interviews. Practice actually solving problems, and it's very much about quality, not quantity of problems. So it's about how effectively do you use each problem you prepare on to actually get better. So, cracking the coding interview has hints. They're there because, to help you, yes, but in the ideal world, you would really, really try to avoid using those hints. So you really want to get better at solving problems. You don't just want to have seen a whole bunch of problems before you start interviewing. Okay, so we're just about done here. But if you forget everything else, a couple things I want to just really, really highlight for you. Create a big input, nice and big, generic. Put yourself in a position where your example input makes you do work. And then walk through it instinctively. Get that output like you would if you have never seen a computer in your life. So just walk through and get the manual input. Walk through the input and get the output manually. And then don't code until you're ready. That means don't code until your interviewer wants you to code and until you know exactly what you're doing. Last thing. Keep in mind that, I've talked a lot about the technical side, but it's also about being a great teammate. So that's about being nice and supportive and receptive to feedback and suggestions. And you can, stand up for your perspective, but don't argue excessively. It's about the behavioral questions and your prior experience too. Doing hackathons, that kind of thing, which I hope everybody here is doing. That's all really great, useful stuff. That stuff absolutely matters. And then the other thing I want to just mention here is your perception of how you're doing is not actually predictive of your performance. So what I mean by that is that the people who walk out of interviews and they're like, oh my God, I bombed that interview, has no real reflection of how they actually did. And the people who think it went great, not reflective of how they actually did. And the reason for that is that people who, when you look at how you performed in an interview, you're usually evaluating it on one of two criteria. One is you think that you did well or poorly based on how much you struggled through that problem. But the thing is that your perception there is relative to how much you've struggled through other problems. What you don't know is how hard is this problem and how much has everybody else struggled. So you're evaluating it on a completely different basis than I am. It's sort of like if you're in school and you get back a test and you're like, you see that you got a 67 and it's a curved exam. And you see that you got a 67 and you raise your hand and you're like, excuse me, professor, but what was the, I see, what was the mean and median and standard deviation on this test? And they're like, I haven't calculated that, which is, by the way, always bizarre when that happens. But you see that 67 and you don't know what the score is out of, and you don't know what the mean and standard deviation is. You cannot interpret that whether that's an A, B, or C. And it's the same kind of thing in an interview. You see how long it took you to solve this problem. You don't know what the norm is. You don't know if you did much better or much worse than the norm. All you know is how you did relative to how you normally do, which is not particularly useful information. The other way that people interpret how they did is they evaluate it based on how they think their interviewer acted. Did their interviewer seem to like them or not like them? And the thing is, that's not particularly predictive either, because one, the biggest driver in how an interviewer treats you is their personality, not your performance. And also, interviewers aren't necessarily nicer because you're doing better. In fact, often when somebody's doing better, it can seem your interviewer is less nice because they're trying to kind of push you harder. Whereas when someone's really struggling, I might be a lot more likely to be like, oh, it's okay, that's great, awesome. So it's not particularly predictive of how I treat you. Is not, I'm always supposed to be nice and friendly and super bubbly and supportive to you. If I'm not, that's on me, and it's not really a sign of how you're doing. So what I want to leave you with here before I go on Q&A is just do your best, keep working at it. If you think you're doing poorly, try to keep what I said in mind, that your perception of how you're doing, not at all reflective of how you're actually doing. If you think, oh my God, I don't even know how to do this problem, great, that's normal. It's okay to feel that way. So I'm going to turn over to Q&A right now. If you have, if you want access to the slides or some other materials, you can shoot me an email, prep@gayle.com. That's just an auto response, so it'll shoot you back the slides and the handout I talked about earlier and a few other things. So with that, I will turn it over to Q&A.
All right, thank you, Gayle. That was a really interesting keynote. It was really good, and yeah, guys, check out the link. It will be posted on the YouTube. So yep, and without further ado, let's go on to the questions. So this is the first question. This is actually from a close friend of mine. He said, "What are the future difficulties of coding interviews now that everyone is writing lead code for the job?"
That's a good question. I think it's not. I think it'll push interviewers more to asking more unusual questions. It makes the job harder for the interviewer, I think. And I haven't seen it increase the difficulty of the problems, really. I think people have said that. People have been saying that for a very long time. I don't think the data actually, pans out with that being the reality. I think the biggest problem is that I think it's hurt. The amount of interview prep people have doing has hurt candidates, just because it's flipped their mindset to being like, I need to memorize problems, which is not really the right way. And it's also flipped people they're just spending too much time doing this rather than doing projects. So the candidates, each specific candidate who's spending that much time, I think it's backfiring on them. I wish I think that's a probably better world than the world where people did basically zero interview prep. And then we're like, wait, I have to code in an interview? Oh my God. So I'd rather have this world than what it was, back in like 2005. But I really wish we were at more of this sweet spot of like, yeah, spend a couple weeks doing some interview prep, but really actually spend your, freshman, sophomore, junior, senior year actually coding. So I'd rather be like, do some interview prep, but that's, again, I don't think that's hurting other candidates. It's hurting each individual candidate who just kind of spends too much time in interview prep.
So are you saying that basically you mentioned before 6 months is too much, right? So how long should interview prep should be? Because you're mentioning weeks.
I would say I think a few weeks is probably a good sweet spot. I think it probably depends on each person. If you're self-taught, or if you have particularly strong imposter syndrome, then it may be that you want to spend a little bit more time. But I think, if you already know how to code and you already know your data structures and algorithms, a few weeks is probably sufficient. And I'd rather you spend extra time learning how to learning how to be a better coder. And one thing to keep in mind is that people will kind of make this, what I think of as sort of a superficial argument that you need to do a ton of interviews, that like interviews must have gotten harder. Sorry, that's my son in the background.
It's okay.
So when people make this kind of superficial argument that the amount of interview prep must have meant that interviews are getting harder, keep in mind, there are so many more people who are hiring software developers now than were hiring software developers 15 years ago. So yes, there are more software developers in the market. There's more interview prep. That's all totally true. But you have like Google, you have so many more large tech companies. You have so many more non-tech. Everybody needs this. Like every large company needs a staff of engineers. And so like the market's kind of balanced out a little bit, where I don't think interviews have gotten a lot harder.
Interesting. And on that note, somebody's asking, because people really want to go to FANGs, right? So people are asking, what are the top 5 tips to get into FANGs?
I'd say, do some interview prep, but I think that's kind of obvious. I think most people probably know to do some interview prep. Mm-hmm. If you take a step back, there's a kind of a couple major steps. One to doing that. One is you have to be able to get your resume in front of a recruiter, or even an engineer who can pass it on to a recruiter, right? So, frankly, when people talk about good universities, that's unfortunately probably one of the biggest advantages of a top university, is just it makes that one step a lot easier, which is, by the way, incredibly unfair for a lot of reasons. But the reality is that does help. But there's also some other ways of compensating for that. You can go to hackathons. You can reach out to recruiters directly. You can establish, you can create portfolios on GitHub and your own personal website. But you need to find a way of getting somebody to pick up your resume. So, kind of create a framework of how am I going to do that? That's easy for some people, harder for others. Then it's, okay, someone picks up my resume, and now what? How do I make them want to interview me? And projects, hackathons, things like that are going to be a big piece there. Knowing multiple languages, but you don't need to know a dozen. So it's useful if you know, C, Java, and Python. That'll put you in a pretty good boat for those companies. C or C++ shows that you know pointers and some of the lower level stuff. And it's not universally known anymore among college students. Java is a popular language, is going to show a certain amount of object-orientedness. And Python's just happens to be a really useful language for lots of things, and obviously is also object-oriented. So have a reasonable diversity of languages, and have projects, especially independent projects, stuff that show that initiative. And then the kind of final step of that is, okay, so someone picks up your resume and they say you want to interview you, and how do you do better in interviews? And that's going to be about, yes, coding interview prep, but also don't forget about system design. Don't forget about behavioral questions too. And so think about that framework of optimizing each step.
Think about the process. Okay. And because you also mentioned that seeing recruiters, right? But people are applying through Indeed. So, and if you let's say for example, you're a new graduate, you don't have any experience, you didn't do co-op, you didn't go to a good school, but you kind of did some coding questions. You feel like you understand, right? But you don't have the background, right? The support. What would you do?
So recruiters, in an ideal world, recruiters want to see two things. One, you'd be a good employee, and two, you'd actually pass the interviews. It doesn't help if I'm a recruiter and I'm looking at a resume and I'm like, wow, this person would be a great employee, but they wouldn't pass their interviews. It's obviously unfortunate, but I'm like, there would inherently be, if I knew that somebody isn't going to pass the interviews but would be a good employee, there would be no purpose in interviewing them. So in an ideal world, you want to be able to convey both. So being a good employee is shown through projects, and if you don't have to have an internship. You can do independent projects, and they can be anything. It really doesn't matter that much. You can get involved in open source. You can do hackathons, whatever it is. I would love to see people, especially because hackathons are so common nowadays. I would love to see people having their own project that they've been spending months actually working on developing. That would be somewhat of a differentiating factor, rather than these one-off small projects at hackathons. But hackathons are great too. And then the other piece is showing that you can pass the interview. So if you can show something like a top coder score, or a hacker rank score, that kind of thing, it's a little bit cheesy, but it can at least show that you can pass the interviews.
Got it. And another question is, how much time should be put towards practicing mock tech interviews with friends versus solving legal style questions independently?
I think it's hard for me to give an exact breakdown, but I would do a mix. And actually, I would say that one of the things that I found when I'm prepping people to be really valuable is spending time actually as an interviewer as well. Because when people do, you learn a certain amount from interviewing, from being the candidate. But when you're actually on the other side and acting as an interviewer, you see this different side of it, and you get a better feel for like, oh, this is why. Like, interviewers gravitate towards the same kind of behavior And once you've been an interviewer, particularly you've done it, a dozen or two times, you really get a feel for why is the interviewer doing certain things. And so see both being the mock candidate and the mock interviewer as important pieces of the puzzle.
Okay, I agree. And another question is, which is weighted more in interviews, data structures and algorithms or product development in projects?
I would like to be able to tell you projects, but
Reality.
reality is that it's more, I think the projects are important in getting the interview. But realistically, it depends on how much experience you have. But realistically, if you're coming out of college, I'm going to take the person who does well in the coding interviews over the person who does poor. Like I would, if I have to pick between one person who's doing well in coding interviews and doesn't have a lot of projects over somebody who has projects but isn't doing well. Because the person who's done projects, sometimes that, first of all, that can be for a lot of reasons that are like, if the person's struggling in the coding interviews, I'm going to wonder if they're able to solve hard problems in the real world. And so realistically, the coding interviews are a deal breaker issue. There's some leeway here where somebody who's doing borderline but has awesome projects can get hired. But realistically, if a company's doing coding interviews, it's probably going to be a deal breaking issue if somebody is performing poorly.
Okay.
But I will say it can depend. I'm talking a lot when I say that. I'm talking a lot about the Google and Facebooks of the world, the big kind of top companies. There's a whole lot of interviewers who, you can have startups who are where an interviewer or hiring manager hates this coding interview process, does it because they're told that they have to, and they end up being like, I'm going to disregard what I'm seeing. I'm going to hire based on their actual experience, even though I'm forced to do this thing. So you can have exceptions like that, but for the most part, if somebody's doing these interviews, it's because it's going to be a deal breaking issue. Especially for somebody who doesn't have much experience in the first place.
Exactly. Because right now I'm also, my company, I also interview people, but I'm not as good as you. But what's the word? We do hire based on the projects. But however, when I saw your slide, you mentioned pseudocode. Actually, my interview was actually done in pseudocode. So it's very it was very interesting. Whereas most times we're used to these type of questions. So the next question is, how do we go above and beyond when answering these? How do we go above and beyond when answering the questions?
So one of the things that I don't see a whole lot, but I really like, is when I interview somebody who seems excited to solve problems. So most people are just kind of like, they ask a question, they're like, okay, great, and they'll go through the motions, they'll do it. But when I interview somebody who's like, ooh, that's a cool problem, let me think about that, and they seem excited and they want to be there, that one thing is unfair is maybe there's a little bit of being like, oh, I like being with it, like they're flattering me a little bit, which would be an unfair part of the thing. But the other thing is that makes me feel like they, in the real world, if they got the job, that they're going to be there interested and excited to solve hard problems, which is a really great technique, tactic or trait in an employee. It also means that they're excited to be there, and they seem like somebody who's going to be more likable, a better teammate from a technical perspective because they like solving hard problems, but also a better teammate just because they're enjoyable to be with. And that's something I don't see. I've seen it, a good amount, but it's certainly a minority of people. But yeah, it's always great to interview somebody who seems excited about solving something hard.
Yeah, I like to see people excited too. It shows that they're very interested. They haven't seen a problem before. Just genuine.
Yeah.
But unfortunately, though, it's 10:55 a.m. PST. We're ending at, sorry, we're at 10:55 a.m. PST. But we've got a couple questions, but we want to be respectful of the time. As we know, we signed for only 1 hour. So if you want to continue, we can continue on. However,
Sure.
right?
I have a
Okay.
few more minutes
Okay.
if other
Awesome.
people have more questions.
Yep. A lot of people have, a lot of people have questions. So another question is, uh, is it okay to ask the interviewer for advice towards the end? Well, that's a weird question. Is it okay to ask the interviewer for advice towards the end of an interview?
So ask the interviewer for advice at the end of the interview.
Yeah.
So I think like you can ask the interviewer for advice. I've never seen somebody do it before. My guess is it would put the interviewer in kind of an awkward position where they're like, I think I'd say this. I think it depends on the rapport you have with the interviewer. As a general rule, no, I wouldn't do it. If you feel like this is the exception and you feel like this interviewer is really, if they've already started to give you advice about your career or something like that, and if they've already engaged that conversation, and you feel like there's something different where you feel that you can do that in this case, great. I think you have to make you have to make a call then and there. I wouldn't do it as a general rule, but I don't think it's a big deal. I don't think it's going to be a big problem. If you feel like this is an appropriate time to do it, then I'm not going to tell you not to do it. But I'll take a step back though and say, because I think this is a common question a lot of people ask is it okay to ask your interviewer for hints during the interview? And I really want to caution people not to do that. And the reason is that when I'm an interviewer, I am making at all times basically a conscious decision about whether or not to give you help. And when I don't, it's because if you think about an interview as a series of hurdles, if I'm not helping you pass that hurdle, it's because I want to see what you can do on your own. I'm making conscious choice to tell you in my head, say, I'm not going to give you this hint. As soon as because I want to see you get past that hurdle by yourself. And if you can't, I'll help you, but I want to give you that chance. As soon as you ask me for a hint, it changes the dynamic. Where now, on one hand, I think at a technical level, I want to see you accomplish this hurdle, pass this hurdle by yourself. But now you've changed the dynamic. And if I say no, we're back to kind of square one. You're continuing to pass it, but your morale is messed up. You feel rejected. You maybe feel embarrassed. And you've changed the dynamic where I might feel pressured to give you a hint that wasn't actually in your best interest, but now I have to do it because you asked. And it's just not a good idea. Don't ask for hints. What you can do is tell your interviewer, just talk more, communicate more clearly about what you're thinking, how you're thinking about tackling the problem. And then they have more information with which to make a decision about whether or not to give you a hint. But don't ask them for a hint unless they tell you can for some reason. I would never tell an interviewer, a candidate that, but if they tell you can ask for hints, then that's their rules.
The interviewer should be the one who's in charge of the pace,
right?
Essentially. Right. So the next question is, what if I miss an edge case while giving my solution to interviewer, and how do I make sure I consider all the edge cases while coding?
So I mean, there's different types of edge cases. There's edge cases which are like, oh, you didn't check to see if the array was null, and that could lead to a bug. That kind of edge case, some interviewers will care about more than others. There's other edge cases which it's an edge case where the problem gets exposed, but it's a much deeper problem in your algorithm. And so how big of a deal it is really depends on the situation. I'd say minor issue in all cases, but sometimes it's really, really minor, and sometimes it's like a moderate issue. What I would do with edge cases is I think about the kind of stupid ones and the interesting ones. So the stupid ones are, did you check to see that the array was empty? Did you check to see this? No, did you do this and that? These are kind of the stupid, uninteresting ones. The interesting edge cases might be things more like that there is a problem when the two strings are identical, where your algorithm actually needs to significantly shift, something like that. So breakdown as like, you can almost always cover the like stupid ones. Those are the boundary checks. and then think about what are the more interesting things. And that requires just dissecting your algorithm and really think about where it can go wrong. Be careful though to not fix any bugs, but this happens a lot with edge cases by just putting in a lot of checks. So sometimes people will, they'll have a bug that appears when the two strings are the same length, and that's what exposed the bug to them, but that wasn't the real bug. Is they always have an off by one error. So be careful when you fix things for edge cases and really see if that's an edge case issue or if it's actually a bigger problem. Often it's actually a bigger problem in your algorithm.
I agree. This question it's a really good question. I actually like it a lot. During interview session, sorry, not this. uh, what are your views on interview questions being DAG structures and algo specific, even though the job position doesn't really need the skill? Example, front end position.
Good question. So it's something that I talk with interviewers a lot in training. So the core of what these questions, when I do interview training, I tell interviewers that if it's a back end position, here's your fair game topics. You can ask about arrays and binary search trees. You can assume the candidate knows what a balanced binary search tree is. You cannot assume they know the specifics of red-black trees or things like that. I give them a list, and it's basically the obvious stuff that if you have a CS degree, even if it was from 10, 15, 20 years ago, you would not have forgotten what these things are. At least if you've been coding for 10 years and you're going to still remember what a binary search tree is, things like that. But I tell somebody you cannot ask about Dijkstra's algorithm or, map reduce or these more complex topics. You want things that, unless that's actually a job requirement for that specific job. For front-end positions, actually, even for back-end positions, I still tell people, in an ideal world, you still wouldn't even care about that. You could stick to in fact, my favorite interview questions are things that involve only like arrays and you have to know what sorting is. Things that I've never seen somebody who doesn't know. It's like arrays, sorting, and hash tables. And this way, if somebody struggles on it, it's solely because of problem solving, and it's not because they feel like they don't know trees well enough. And those questions, what's great is those questions work just as well for front end as for back end. And they are really, truly problem solving questions. And problem solving, the ability to have something hard and figure out how to do it, is a core job requirement for every kind of coding job. Coding is fundamentally a thinking job, and those questions are about how well can you think through hard problems. I would like front end positions to really try to stick to just, arrays, strings, hash tables, things, really basic stuff. In practice, it can be hard for people to find challenging enough problems that only stick to those. But I do think it's ideal if you can. And so in trainings, I don't forbid usage of stacks and trees and the slightly less obvious topics, just because I think it becomes too hard for interviewers to do that. But in an ideal world, I would fully encourage interviewers to especially front end interviewers, to stick to just like arrays, strings, hash tables.
Okay. Yeah, I work front end too, so I would not want to see red those AVL trees.
And that's not fair for anybody. I mean, you only know AVL trees if you've studied those for interviews. I mean, it's not like something that you're going to be using in the real world. And even if you had a job where you happen to use AVL trees and red-black trees a lot, like, okay, well, that can easily be something you train people on when they start. You don't have to interview people on it. And if you do think you need to interview on it, then that should actually be something every candidate gets interviewed on. It shouldn't be like, this topic is fair game. There should never be a situation where someone's like, AVL trees are fair game for interviews because they're important for the job, but not so important for making sure everybody actually does that. That's this weird middle ground that shouldn't happen.
Another question is, I think you already answered it, but during interview session, how will I know if my code can't be optimized anymore? Would asking the interviewer that's all, if it would asking the interview be rude? But yeah, you can answer.
Good question. So there's you mean you could ask your interviewer, but I try to figure out yourself. There's a topic I didn't talk about today, but that I talk about in Cracking the Code interview called best conceivable runtime. And this is not the same thing as best case runtime. Best conceivable runtime means, given the constraints of the problem, what is theoretically the best runtime you could imagine? So imagine, for example, you're given an array and you're asked to find all the prime numbers in the array. It is obviously impossible to do that in better than linear time, because you can't even look at all the elements in less than linear time. So clearly you cannot find all the prime numbers in an array in less than linear time. Therefore, if you come up with an algorithm and you've gotten to linear time, you must have the most optimal algorithm possible. There might be other algorithms equally optimal, but you certainly cannot get it more optimal than that, because you're already at the theoretical maximum or theoretical fastest runtime. If you want to merge two sorted arrays, again, can't do that in better than O of A plus B time, because you have to touch all the elements. So in a lot of cases, you can look at the problem and think, what is the best conceivable runtime? Again, that's given the nature of the problem, not given your algorithm. It's what is the best theoretical runtime for a problem like this. And if you reach that runtime, then you cannot continue to optimize the time. However, you might be able to optimize the space complexity, or you might be able to simplify your solution. If you've reached the best conceivable runtime, you cannot optimize the time anymore.
Got it. And another question is, should we include hackathons in our CV?
Yeah. I mean, I think I think in the US, now this is a culturally based question. In the US, we use generally resumes and not CVs. I actually don't know what Canada does right now. I kind of feel like they use resumes more, but in the US, we use resumes. Resumes should stick to one page. Generally, certainly anybody less than about 10 years of experience will stick to one page. More than 10 years, sometimes you go more than that, but generally it's one page. And so it's about what is the best one page of information you can give. And keep in mind that interviewers tend to just sort of skim your resume. They look at it for it really is like 15 seconds before making a decision. And all I need to do with your resume is I need to put it into the interview or the no interview pile. So what's the best stuff to put that'll make me put it into the interview pile? For most people coming out of college or recent grads, listing hackathons is probably going to make that cut of being like, yes, that would be good to put in the one page. But if you have somebody who's exceptional, has all these other things, you may start cutting that information, particularly if you haven't like won any awards or things like that.
Okay. We have about 3 more questions. So is Golang? Well, we stopped the questions actually. So is Golang a good language to start with, and does it have good opportunities?
Yeah, I don't know that much about it. My guess is that, I think it's a reasonably popular language these days. There can be a sort of a interesting middle ground where it's, the job market is about supply and demand, not just supply of jobs. So, or not just demand. So there may be less demand for that language relative to, say, Python, but there may also be less supply of candidates. So you may find that I'm going to put that it as a language that isn't 100% mainstream, meaning that like I'm keeping my mainstream bucket as like Java, Python, and very, very few languages. And so it might be actually hitting a nice middle ground of a really sweet spot where it's like there is enough demand for candidates and not enough supply of candidates. So you may actually position yourself really well that way. Yeah. But honestly, I would tell people to view themselves. One of the best things you can do is, especially if you're looking at like, Google, Microsoft, Apple, etc., Facebook is view yourself as a great software developer first and foremost, and not I'm a Python developer, I'm a Java developer. If you are a software developer, you happen to be using this tool, but that's not who you are. You're a software developer. You just happen to be using one language right now.
Yep, I agree. The language, you should be very agnostic, I guess.
Yes.
Right? So another one is, our cover letters. Should time be spent tailoring a cover letter for each company, versus using a generic cover letter?
Yeah, I mean, the reality is that people's cover letters just suck. Like, it's so rare that I see a good cover letter, and recruiters have all basically hit the same point where people's cover letters are bad across all jobs. Engineers, I don't think engineers are doing worse cover letters, but they're also not any better. And recruiters just don't care about cover letters. If you are there is a 1 or 2% of candidates who actually write a great cover letter who helps them. And the other, 98% are writing things that are just kind of crappy. So what I tell you to do is, if you want to shoot for that 1 or 2%, great, but you're already probably writing a really good one. So maybe you can, optimize it and actually write the rare, really good cover letter. Otherwise, just write something fairly generic that you can easily customize. Make it good enough, and don't worry about it, because the reality is recruiters aren't reading your resume or aren't reading your cover letter because they generally suck.
And generally, it's like, I don't normally get people coming back to me when I book letters. Okay. The last question is, it's actually from a friend. So basically, this person has he has experience. He built a website. It's online, and he did it for 4 months, and he also did an internship at his school, at his school, keyword at his school, and it was also 4 months. But right now he just has McDonald's on his LinkedIn from maybe for 2 years. So he also keep doing McDonald's. Should he remove that, or should he keep it into his resume?
Yeah, I mean, I assume if you say McDonald's, I assume you're probably not talking about like a software engineering position. McDonald's,
Yeah,
you're probably
normal.
talking about just a cashier kind of position. Yeah, I'd remove that. I think it can unfairly stigmatize you, and it can also make someone, they first glance at your resume and they see something that looks completely irrelevant, and you're probably better off having no job than listing that. And there's nothing, by the way, at all dishonest about taking stuff off your resume. Your resume is not a comprehensive view of what you've done. It's a list of the highlights. So there's no problem with just not having that on, to just taking off a job from your resume. I just rather people spend their time, I'd rather the person looking at your resume spend their time looking at your projects and other things than seeing McDonald's. Now, that said, you have to make a decision based on what the average person will react, and that's how I think the average person will react. There can be people who look at 2 years of McDonald's and appreciate the dedication, the ability to do grunt work, the ability to have held on to a job that kind of sucks and not get fired. So I think the average recruiter, the average software engineer will look at that and just be distracted by the McDonald's, but there's going to be that other portion of people who see it as a plus.
Does that tie into the one page? Because the one page is supposed to be really good, right?
Yeah. So, it ties to the one page. Like with one page, I probably wouldn't spend time focusing on that. And even if it was a longer resume, you still only have 10 or 15 seconds of attention from somebody. So you still don't want them to get distracted by that kind of stuff.
Okay. Well, Gayle, thank you so much for coming at DevHacks. We really appreciate you to come here. Yep, guys. Unfortunately, this is the end of the call. This is the end of the Zoom. If you guys have any questions, feel free to message me on Slack, and I will be dropping the link of Gayle's, it was website, right?
Yeah,
So,
well, I had a what I did with people is an email auto response. It's
Yeah,
prep@gayle.com, which is GAYLE.
yeah,
Prep@gayle.com.
I'll be dropping that on the YouTube and Slack as well. All right, Gayle. Thank you.
All right. Thank you so much.